Hello everyone. Today I am starting module 2 and this is your first lecture. So first of all, let's discuss the syllabus of module 2. In your syllabus, the topic name is single variable calculus. Module 2, the topic name is single variable calculus. Okay. So first in your syllabus, this is Rolle's theorem. Rolle's theorem. Second, you have mean value theorem. Mean value theorem. Okay, and in your syllabus there are total 4 types of mean value theorem. First one is Lagrange mean value theorem. Second one is Cauchy mean value theorem. Third one is Taylor's mean value theorem. Taylor's MVT or Taylor's mean value theorem. Okay, and Taylor's mean value theorem, this is 2 types. Taylor's MVT with Lagrange remainder. Okay, Taylor's MVT with Lagrange remainder, and the second one is Taylor's MVT with Cauchy remainder. Okay, and the last MVT is Maclaurin's MVT. Maclaurin's MVT. Okay, now and this is the first part, and the second part is, in second part you have sequence and series. Sequence and series. Okay, and in this portion you have total 6 tests. First one is p test. Number 2 is comparison test. Comparison test. Number 3 is D'Alembert ratio test. Ratio test. Number 4, Cauchy root test. Number 5, Rab's test. And number 6 is Leibniz test. Okay, Leibniz test. Okay, also you have in your syllabus 4th topic, this is power series. Okay, and the last topic is Taylor series. Taylor series. Actually we will complete this topic Taylor series in this Taylor's MVT. Okay, so let's start. Today's topic is Rolle's theorem. In this video we will discuss about Rolle's theorem. So before starting Rolle's theorem, first of all we have to know how to find out a function is continuous or differentiable. In this type of problem you have to remember some important result. Okay, for example, first result is every polynomial is everywhere continuous and differentiable. Everywhere continuous and differentiable. You have to remember the result. Second result is graphically how to know that a function is continuous or not. The process is, if you can draw the graph draw the graph without lifting the pen. Sorry. Without lifting the pen. Okay. If you can draw the graph without lifting the pen, then the function will be, or then the curve will be, then the function is continuous. Number 3 is, if there is any sharp edge, then the function is not continuous, is not differentiable at that point. Okay, for example, let's say I am drawing mod x, graph of mod x. You know what is the graph of mod x? This one. Here you can see that I can draw the graph without lifting the pen. Obviously mod x is continuous. Okay, and here at the point origin there is an sharp edge. That means mod x is not differentiable at origin. Clear? Let's draw another graph. Let's say sin x, sin 0 0, sin pi by 2 1. So this is the curve of sin x. Okay, and you can see that I can draw the graph of sin x without lifting the pen. So obviously sin x is continuous, and there is no sharp edge in this graph. This point is not sharp edge. Sharp edge means there will be the change of direction, totally direction. This is the point of sharp edge. Okay, but this here in the curve of sin x there is no sharp edge. So sin x is everywhere differentiable. Okay, so sin x is everywhere continuous, sin x is everywhere differentiable. Similarly, cos x is everywhere continuous, cos x is everywhere differentiable. Okay, so let's come to the main topic of your syllabus, that is Rolle's theorem. Rolle's theorem. Okay, suppose you are given a function f, function of two variables x and y. Okay, or just single variable, because the topic is single variable, na? Single variable calculus. So let's say you are given a function f of x. Okay, and you are given an interval, closed interval ab. Okay, remember this type of interval, this is called closed interval. And this type of interval, this is called open interval. What is the basic difference between open interval and closed interval? Closed interval means it is containing the two endpoints a and b. Okay, and open interval means it is not containing the two endpoints a and b. Okay, just two differences. So we have two functions fx, we have a function fx and an interval, closed interval ab. Now if it satisfies three conditions, first one is f of x is continuous on closed interval ab. Okay, second condition is f of x is differentiable in open interval ab. These two conditions. So first condition is fx is continuous on closed interval ab. Second condition is fx is differentiable in open interval ab. And the third condition is the functional value at the endpoints will be equal. So fa is equals to fb. functional value at the endpoints are equal. So if these three conditions hold, then there exists at least a point C belongs to open interval AB such that f dash c, this is equals to 0. What is f dash c? F dash c means first derivative of f at the point c, that will be 0. So according to Rolle's theorem, if a function satisfies these three conditions, then there exists at least a point c. At least, that means there may exist more than one point, but definitely you will get at least a point. Okay, so there exists at least a point c belongs to open interval AB such that f dash c is equals to 0. Okay, so let's understand graphically what do you mean by this statement. Suppose this is our x-axis and this is our y-axis, x and y, and there is a curve, let's say this one. This is the curve of, this is f of x. I can draw the curve without lifting the pen, so that means fx is continuous, and there is no surface in this curve, that means fx is differentiable. Okay, that means first two conditions are satisfied. Let's say this point is A, this point is B. Okay, this point is A and this point is B. Okay, now what is FA? FA means this straight line, na? This straight line is FA and this straight line is FB. So according to this figure, almost FA and FB is equal. FA and FB are equal according to the figure. So obviously three conditions are satisfied. Function is continuous, function is continuous in closed interval AB, differentiable in open interval AB, and the functional value at the endpoints are equal. These three conditions hold. Now it is saying that there exists at least a point C belongs to open interval AB such that f dash c equals to 0. So in open interval AB, that means between A and B, there must exist at least a point C. Let's say this point is C. Okay, and at this point, what do you mean by f dash c? F dash c, what is meant by first derivative of f? When in class 11 or 12, when we have to find out the tangent of a function, we have to derive the function, first derivative of the function. Okay, then we can calculate the tangent. This is the same process. F dash c, this represent that the tangent of the function f at the point c. Okay, f dash c, that means tangent of the function f at the point c. Okay, now f dash c equals to 0. What do you mean by this? F dash c equals to 0. F dash c equals to 0, that means we can say that this tangent is parallel to the x-axis. Okay, f dash c equals to 0, that means if I derive this, we can say that f of c is equals to some constant k. Okay, and f of c means functional value at the point c. And what is the equation of a straight line parallel to x-axis? Some y is equals to some k, and here it is given fc equals to k. That means it is the parallel of x-axis. So here f dash c, the tangent is parallel to the x-axis. So this is the tangent. Okay, this is the tangent, f dash c equals to 0. This is the geometrical interpretation of Rolle's theorem. Now question is, what do we mean by at least? Suppose let's draw another graph. This is x-axis, this is y-axis. Let's say the curve is suppose this is the curve. Okay, and let's say this is the x-axis. Okay, so let's say this point is A and this point is B. Obviously this is FA and this is FB. Okay, and between A and B you can see this is a point. Let's say this is C1, this is another point, let's say this is C2, and this is another point, let's say this is C3. You can, here you are getting 3 points where the tangents are parallel to x-axis. Yes or no? That's why it is given that at least 1 point. That means there is a possibility that you will get more than 1 points C. Okay, now let's solve some problem using Rolle's theorem. First question. Verify Rolle's theorem. Verify Rolle's theorem for the function fx is equals to x square minus 6x plus 8 in the interval 2, 4. Okay, verify Rolle's theorem for the function f of x equals to x square minus 6x plus 8 in the interval 2, 4. So let's solve. Solution. Okay, here given f of x equals to x square minus 6x plus 8. Okay, this x square minus 6x plus 8, this is polynomial na? And I already have told you that polynomial is everywhere continuous and everywhere differentiable. Yes or no? Polynomial is everywhere continuous and everywhere differentiable. So first two conditions are satisfied, that it is continuous in closed interval 2, 4. Just you have to write the statement that since this is the polynomial and we know that polynomial is everywhere continuous and everywhere differentiable, so first condition fx is continuous in closed interval 2, 4 and fx is differentiable in open interval 2, 4. Yes or no? Now just you have to find out the values at the endpoints. So f of 2 and f of 4. So what is f of 2? F of 2 means 2 square, so 4 minus 12 plus 8, so this is equals to 0. Similarly f of 4, so this will be 16 minus 24 plus 8, so again this is equals to 0. That means it is satisfying the third condition also, that fa is equals to fb. It is satisfying the third conditions also. So obviously it is satisfying all the three conditions of Rolle's theorem. Okay, now obviously according to the Rolle's theorem there exists, this is the symbol of there exists, at least a point C belongs to open interval 2, 4. Open interval 2, 4. So this indicates that the point C must not be between the 2 points 2 and 4. Okay, C must be between the intervals 2, 4. Okay, C cannot be equals to 2, C cannot be equals to 4. C must be between 2 and 4. Okay, and if the point C lies in this interval 2, 4, then we can say that Rolle's theorem is verified. Okay, if it is satisfying these three conditions, we cannot say that Rolle's theorem is verified. Okay, we can say that it is satisfying the three conditions of Rolle's theorem, but we cannot say it is Rolle's theorem verified. It will be verified when we can verify that the point C is in the interval 2 comma 4. Okay, so find out f dash x. What is f dash x? F dash x equals to 2x minus 6, and according to Rolle's theorem, f dash c equals to 0. That means you are getting 2c minus 6, this is equals to 0, so c is equals to 3, and 3 is in the interval 2 comma 4, yes or no? 3 is in the interval 2 comma 4, so hence you can say Rolle's theorem verified. Okay, Rolle's theorem verified. Let's solve another problem, almost same type. Second question. Okay, suppose the question is verify Rolle's theorem of f of x equals to mod x in minus 1 to 1. Verify Rolle's theorem of f of x equals to mod x in minus 1 to 1. Acha, in minus 1 to 1, if I draw the graph, suppose this is the point minus 1, this is the point 1. So in this interval, the graph will be this. Okay, this is the graph of mod x. Here you can see at the point origin, there is a surface. So you can write that the function is continuous in minus 1 1, but it is not differentiable in open interval minus 1 comma 1, or you can say it is not differentiable at 0 comma 0. Okay, which is or it's just simple at 0, which is belongs to open interval minus 1 comma 1. Okay, that is it is not satisfying the second condition of Rolle's theorem. Okay, hence Rolle's theorem is not verified. Clear? Hence Rolle's theorem is not verified. Suppose the function is given f of x equals to sin x. Okay, suppose the function is given f of x equals to sin x, and the interval is given minus pi to pi. Again, we know that sin x is everywhere continuous, everywhere differentiable, and f dash x, that means cos x equals to 0, that means x is equals to pi by 2, and pi by 2 belongs to this interval minus pi by 2, minus pi to pi. So obviously f of x is equals to sin x, it is satisfying the Rolle's theorem. Yes or no? Okay. Now let's take another example. Suppose x cube minus 4x, x cube minus 4x. Okay, and the interval is given minus 2 comma 2. First, obviously it is polynomial, so first two conditions satisfied, continuous and differentiable. Now third condition, you have to find out the functional value f of minus 2. So this will be minus 8 plus 8, this is equals to 0, and f of plus 2, so this will be 8 minus 8, so this is equals to 0. That means all the three conditions are satisfied. Okay, now result f dash x, f dash x equals to 3x square minus 4, so f dash c, this is equals to 3c square minus 4 equals to 0. That means c square equals to 4 by 3, so c is equals to plus minus 2 by root 3, plus minus 2 by root 3. That means it will be this is equals to plus minus 1 point something, na, 2 by root 3, 1 point something. If it is 1 point something, so obviously it is belongs to open interval minus 2 comma 2. Yes or no? So this is satisfying the Rolle's theorem. So in this way you can solve this type of problem, and Rolle's theorem is very simple concept, very easy, and you will get very easy problem from this topic. Okay, thank you so much.